Hello and welcome. In this video, let's take a closer look at functional dependency and the various Armstrong's interference rules. At the end of this video, you will be able to describe functional dependency and state Armstrong's interference rules. What happens if your database is not well designed? It leads to inconsistency of data where the same data does not match with each other in various tables, and redundancy of data by storing duplicate values in a database. So, how will you sort this issue? By using functional dependency. Yes, functional dependency avoids anomalies in database and ensures data integrity. Functional dependency exists when one attribute uniquely determines another attribute. One of the attribute is called determinant and the other attribute is called determined. For example, if A is the determinant and B is the determined, then we can say that A functionally determines B, otherwise we can say that B is functionally determined by A. The graphical representation of functional dependency is shown on screen. Now, let us take an example of student relation. This table has student ID, student name, city, and state as its attributes. Suppose if I ask, to which city does Adam belong to? Will you be able to answer for this question? No, right? Because there are two students with the same name, Adam. And also, you do not know which Adam city has been asked. In such cases, we need to have some unique field which can determine the city of Adam. Suppose if I ask in which city student ID 145 belongs to, then definitely you will be able to answer this question because student ID has unique values. Hence, the city of student ID 145 is London. Well, we have found that the student city is uniquely determined by student ID. Similarly, we can say that student ID determines student name also. In order to find functional dependency in a database, a set of rules are used. They are called Armstrong's axioms, which is also referred as inference rules. Armstrong axioms are made up of 6 distinct axioms: reflexivity rule, augmentation rule, transitivity rule, union rule, decomposition rule, and pseudo-transitivity rule. Now, let us look at each one of them. Reflexivity rule states that if B is a subset of A, then A functionally determines B. Let us take the student table as an example. If student name is a subset of student ID, then we can say that student ID functionally determines student name. This means only if we know the student ID, then we can determine the student name. The next rule is augmentation rule. According to this rule, if A functionally determines B, then AC can functionally determine BC. Considering the same example of student table, if student ID determines student name, then student ID and city together can determine student name and city. Now let us see what does transitivity rule say. According to transitivity rule, if A determines B and B determines C, then indirectly we can determine C from A. Consider the same example of the student table. If student name is determined by student ID and city is determined by student name, then by transitivity rule we can say that student ID determines city. Now we will look at union rule. Union rule says if A determines B and A determines C, then together we can say that A determines BC. Consider the same example of the student table. If student name is determined by student ID and city is determined by student ID, then together we can say that student ID determines both student name and city. Now, we have another inference rule called decomposition rule or productive rule. This rule states that if A determines BC, then by decomposing it, we can say A determines B and A determines C. Hence, we can also say that the decomposition rule is just the opposite of the union rule. Again, consider the same example of the student table. If student ID determines student name and city, then we can decompose this dependency and say that student ID determines student name and student ID determines city. Now, let us look into the pseudo-transitivity rule. According to the pseudo-transitivity rule, if A determines B and BC collectively determines D, then AC can determine D. Consider the same example of the student table. If stud ID determines student name and student name, city together determines state, then we can say that stud ID and city together determines state. Now, let us summarize what we have seen in this video. We came to know functional dependency exists when one attribute uniquely determines another attribute. In order to find functional dependency in a database, a set of Armstrong's axioms are used. They are reflexivity rule, augmentation rule, transitivity rule, union rule, decomposition rule, and pseudo-transitivity rule. Thank you for watching this video.